Hello everyone, I'm Sana Islami, the student of University of Regina, under the supervision of Professor Kabir and Professor NJ. I want to present the second paper. The title is Prediction of C&D, Great Asphalt and Treated Biomedical Waste during COVID-19 and using a Grey model. The next slide about the introduction, I want to talk about the waste management and the purpose of the project. Firstly, with the increase in the population and development of industrial activities in the economical situation, we can see that there is an increase in the waste generation, in the amount of waste generation. And the COVID-19 pandemic has brought many changes to the environment. We can see that with pandemic, we have various kind of waste that generated during the pandemic and have some effects and risks to the environment. The purpose of this project is to predict this amount of waste generation in the pandemic, and this forecasting can be so beneficial to control and manage waste generation. Grey model and TBGM, with these two models that are from the Grey model family. Family that they just come from the Grey model family. They used to predict the five waste amount of waste generation. C&D, great asphalt shingles only and asphalt shingles mixed and treated biomedical waste are the waste that are investigated in this project. For the next slide about the methodology, we want to talk about the Grey models. Grey model is an appropriate model for using in the situation of lack and weak information. Grey model can be applied to nonlinear and time series analysis data. We use Grey model and TBGM model here to predict the waste generation in the Regina city, and we use the data from 2010 to 2020 of Regina landfill. The first step about the Grey model formula, we can see that there is a prediction equation that we get the prediction data from this step, and then we go through the TBGM. TBGM is a development model of Grey model, which is presented by transformation the original data sequence. So with adding the one step in the algorithm, with add a constant C in the data sequence, we can see that some development in the Grey model, that which is 3BGM, and then we get the exponential for the prediction, which is the formula is here in the slide, and then we get the optimization of background value that we use it to predict the amount of waste generation in the Regina. And then at the end, we use MAPM, MAPE and RMSE to calculate the errors and to validate the models. The next slide, I want to talk about the results. I bring each waste to each graph with the actual value and with the two model prediction results. For the C&D, we can see that for the C&D and asphalt shingles, we can see that there is a decrease in the amount of waste generation during this period, during the 7 years. And so we can see that in some cases there is a decrease even in the COVID-19 period, that just indicates that there is some holes in some projects and that people prefer to stay at their homes and even stop in some doing unnecessary projects, and with the lockdown situation don't use any renewal projects or something like this. Because of that, there is a decrease in the amount of C&D and asphalt shingles mix generation. There can be two increase in the waste generation of C&D in the actual value of the C&D in the 2015 and 2018. We can see that with some policies of permission to construct, in some points we have see that there is a flourish of construction, and there is more waste generation of C&D in some points. And for the asphalt shingles mix, we can see that there increase in 2050, which is related to the residential road renewal program, which is the program that they have some permission, or they have some situation that make more they have more construction, that this is the results of make more waste generation these years. And you can see that 18% decrease in the amount of asphalt shingles mix generation during these 7 years, which is a so significant decrease in the amount of this type of waste. So it can see that so in some cases there is a hold in some projects, and even the lockdown has some significant effects on the amount of waste generation. The next slide is about the grit and asphalt shingles only. You can see that there is an increase in the grit generation and asphalt shingles only generation, waste generation. So we can see that this increase related to the roads, that a project related to the roads have not been stopped due to the icy roads conditions, and because of the heavy winter in the Regina, the project related to the roads have not been stopped. So because of that, there is an increase in the amount of waste generation of related to the grit and asphalt shingles only. And we can see that in the asphalt shingles only graph, there are some up and down trends in the actual value, but there is not any significant change in the amount of waste generation for the asphalt shingles only during this time. Just we can see that between 3,000 ton waste generation to around just changing to the around 2,000 tons waste generation in the asphalt shingles only during this time. And so we can see that there is a totally increase in the amount of this waste that is related to the some situations that population growth and economical growth, or even there is not any stop in the project of related to this kind of waste due to the situation of the COVID-19, and because of that, some situations, because people stayed their homes, and because of the lockdown situation, even crew can work easily and work with this project. For the next slide, we want to talk about the treated biomedical waste generation, and then we go through the MAP and RMSE errors. First, we can see that there is an increase in the treated biomedical waste generation, but there is not a sharp increase. So we can see that maybe because of the fear of the people going to the hospital and fear of COVID-19, people didn't prefer to go hospitals for any issues, and they cancel some unnecessary appointments, like some surgeries and some appointments. So because of that, we just get some data about the total treated biomedical waste. It's not related to just masks, gloves, and other health products that people use during the COVID-19. So people just this type of waste is just calculated from the hospital waste. So there is not any significant change during the COVID-19 pandemic for the treated biomedical waste. Then we can go through the errors of two models. We use these two models, and we want to find out which models can predict the amount of waste generation in better situation, and then get best results to us. We can see here from the MAP graph that TBGM has a less amount of MAP in all of the waste, but except in the CND with a little different in the value. So we can see that TBGM works better than GM Grey model. So this TBGM model is working better in this situation, predict a better value for the waste generation in these 5 waste. And for the last slide of the results, we can see that the RMSE error. So we can see here again TBGM has less error, RMSE error, and we can see that TBGM can work better in prediction of the waste, different waste in this situation. And but in some cases we can see that the Ashwashingas mix about the GM and TBGM models. We can see that Grey model is has a less amount of error with compared to TBGM, but it's because of the related to the actual value that we saw that some increase in 2015, and there is so because of the related to some permission of the construction or some policies that different in some make some difference value in some years. So totally we can find that TBGM model works better in this situation, and we can improve Grey model in each step to get the best results, and TBGM are the best model here to predict the waste generation. For the last slide, I want to talk about the conclusion. We just investigate the 5 waste generation by using 2 models to predict the amount of waste generation in the Regina, and then use the MAP and RMSE to validate these models, Grey model and TBGM. And for the future work, we can work with more development models. For example, when we use TBGM than Grey model, and we can find that TBGM works better, we can use other development models than TBGM with improve it. And we must know that this models works with the lack information. So when we have the big data, we have to use other models to work with this to predict the waste generation. Thank you.